Your FMS is a computer system designed to consolidate and optimize the acquisition, processing, interpretation, and display of certain aircraft navigational and performance data. In other words, a flight management system manages other components. It will have been installed on your aircraft as either SBAS only or multi-sensor system. A heading input and air data information is required in all installations. Heading information can come from an analog magnetic compass system, an AHRS, or an IRS. True airspeed, barometric altitude, and static air temperature are all used by the FMS. Barometric corrected altitude is required for vertical guidance display during approaches and for VNAV below 18,000 feet. Your FMS accepts both digital and analog air data from the air data computer. These are the short-range sensors that can input your FMS. When a DME interface is included, the DME input is considered a short-range sensor. All DME stations within approximately 300 nautical miles of the aircraft position are scanned, and up to 15 are continuously tracked. If a VOR input is provided, it will be used for all VOR approaches. While en route, the VOR will be used only as a last resort sensor and only for those VOR stations within 180 nautical miles. Note that NDB signals are not used by the FMS. However, as we will discuss later, that doesn't mean you can't fly an NDB approach. Nor does the FMS use glide slope signals generated by an ILS. These are the main long-range sensors that can be employed with the FMS. Your FMS can use a maximum of 5 long-range sensors. On the ground, the FMS will receive inputs from the GPS and a heading source. The FMS will send initialization coordinates to the IRS for alignment. Once the alignment is complete, then the IRS will send data to the FMS. However, the FMS will not use the IRS for position calculations unless all other sensors have been lost. The FMS is able to see the air data computer and the radios, but it does not accept their inputs while on the ground. Once reaching 60 knots, the FMS will then accept inputs from the air data computer. When the aircraft rotates, or in the event of a squat switch failure, when it exceeds 150 knots, the FMS will then accept inputs from all remaining navigation sensors. What happens if the FMS loses all of its navigational sensors? To answer this, it helps if you understand how the FMS navigates. Given the last several best computed positions, the FMS computes both a track and ground speed. Add in the heading from the aircraft's heading system and the true airspeed from the air data computer, the FMS then calculates the current wind. The FMS then uses the true airspeed, heading, and wind information to dead reckon. The accuracy of the DR is constantly updated via the sensors. Should the FMS lose its navigational sensors, it will continue navigating via dead reckoning, but the wind information will cease to be updated. As a result, this position will become less and less accurate over time. Scanning DME requires that the FMS interface with a DME receiver that can support both a digital interface and have a blind channel. The scanning DME position is determined by measuring ranges to multiple DME sites of known latitude-longitude position. The FMS searches the nav database to find the 15 closest stations within 300 nautical miles. It then uses the third channel of the DME to interrogate each station for 4 seconds. The FMS automatically corrects the readings for slant range errors. The FMS predicts what the DME for the interrogated station should be. If the distance is not within the required parameters, it is not used in the DME position calculation. The system's own position can typically be determined to within 0.3 nautical miles, although better than 0.1 nautical miles is possible. Accuracy is a function of the number of DME stations available and their relative positions. The more there are, and the greater their dispersion, the better the accuracy.